and get started. Thank you all for being here on a Friday evening. My name is Claire Froelich, and I was a student community manager at Postman, but I just became a curriculum engineer at Postman. We'll be getting into what Postman is in a second, but just a little background about me. I used to be an interpreter and translator for 6 years, and then went to a boot camp and became a full stack web developer. So some of the stuff we're talking about today will be some tips and tricks that you can use in web development, which is also very handy in a hackathon that you're doing now. So we're going to be going over the fundamentals of APIs and a tool called Postman that will help you work with APIs. And we'll even do a little hands-on activity using what's called the GitHub API to see how you can do something real with an application that you build. Thank you all for sharing like where you're from and what you're studying. I see we have a lot of CS grads, some high school and university students. I expect you to know absolutely nothing about APIs, including what API stands for. So we're starting right from the fundamentals. And I guarantee that what you learned today is going to help make you a stronger developer. So what are we going to talk about? We'll go over what APIs are. And to do that, we're going to learn a little bit about networks and network requests in computing. Maybe you CS grads know a thing or two. We'll just make sure everybody's on the same page. We'll learn how to make an HTTP request to an API and then understand what comes back. Finally, and most importantly, we'll learn how to use APIs in our projects. Perhaps you would like to use an API in your hackathon project. We'll see. All right, so without further ado, we keep saying API, but what does it mean? API is an acronym that stands for Application Programming Interface. And the key word there is interface, because an API is really just a contract or an agreement about how code will talk to code. What's cool about APIs is that because it's an agreed way for code to talk to code, it allows you to build automations and integrations because you're always guaranteed to know what shape of data is going to come back. You're always guaranteed to know exactly how to ask for that data or that service. What else is great about APIs is that they help businesses and companies open up their products for faster innovation. For example, you've probably heard of Twitter, you've probably heard of Facebook. These companies also have APIs that, in addition to clicking around the Twitter webpage, you can programmatically talk to Twitter and get tweets. Not by clicking in the browser, but by calling their API. So because Twitter opens up their product like that, people can build apps on top of Twitter. Maybe you've logged into another application using your Twitter account. Maybe you've used an application that tweets on your behalf. That's all happening through APIs. So we can think of APIs in an analogy as a digital restaurant or a waiter at a restaurant. Let's pretend that we're the customer at the restaurant and we want some beef stew. We don't have to know how to cook beef stew. We just have to know that we want it and how to ask for it. So we would just put an order in to the waiter and say, I'd like beef stew. The waiter is going to take our order to the back kitchen and the chef will interpret the order, go fetch the ingredients, chop them up, process it, and give it back to the waiter to give to us. So in this scenario, we have the front end, which is like the lobby side of the restaurant. We don't have to ever see what's happening in the kitchen. We don't have to know how to cook soup, but we have to know how to ask for it. And the API is our middle person that acts as the go-between, a very simplified interface for getting what we want. Same thing with APIs. The wording is just different. Instead of a customer, we have what's called a client. A client is whoever is making a request to an API. That could be a browser, that could be an application. Then we have the server, which is the back kitchen. And this is where all the processing of an order or a request will be done. And the API itself isn't like a physical entity out there. It's a concept of exactly how we can interact with the server. So again, it's analogous with the waiter in the restaurant. The API is the simplified interface for talking to the back kitchen. And if you think there's an API out there for everything, you'd be correct. Basically, if you type any service that you love and then add API at the end of your search, you're probably going to find some APIs out there. For example, you can get the weather from APIs. You don't have to go launch your own weather balloons. You can just make an API call for like a city and it's going to give you the current weather. You can incorporate payments into your applications using the Stripe API, for example. You can automatically send messages to Discord and Slack using their webhook APIs. You can send emails via APIs. So let's say you have an application, when somebody signs up, you want to send them, a welcome to our product email. You can do that with an API. Spotify has an API, so you can programmatically get song recommendations, you can get information about artists, you can incorporate that into your applications. Twitter, Facebook, Google, there's even an API that gives you Kanye West quotes. Literally pretty much anything out there, if it exists, it probably has an API. And I'll also mention, because there's so many APIs out there, these kind of become like little Lego blocks that we can, compose in different ways inside of our applications to build really robust, cool new things. You could build like a weather app that sends messages to Slack that would be using 2 different APIs, for example. All right, so let's talk about how developers work with APIs then and now. In the past, one of the main ways, oh yeah, and feel free to ask questions in the chat as I talk, we'll get to them at the end. But in the past, one of the main ways developers worked with APIs was with a command in the terminal called curl, C-U-R-L. And basically you would type curl and then some endpoint. This is like a location on a server out on the internet somewhere. What this would do is make a request to that server to get some information. And then the server would send information back into the terminal. It would look something like this. As you can see, it's kind of hard to read. As things are in the terminal, it will get lost in the river of the terminal eventually. That's where this tool, the company I work at called Postman, really comes in handy. Postman provides a graphical user interface to interact with APIs, not only to practice calling APIs and poking around them, seeing what comes back, but even for building and testing, documenting, sharing, and collaborating, working on your APIs. Postman is there to hold your hand through everything. As you can see on the left, this is the old curl way of getting data from an API. On the right, it's kind of small, but we can see Postman gives a nice interface, shows us exactly how we can compose a request. And the response comes back all indented and colored. We can save it, we can share it. It's much easier to work with than doing everything in the terminal. So just a little bit more about Postman. It's a collaborative API platform that makes every part of working with APIs simpler. That's why we're trusted by 98% of Fortune 500 companies, over half of the Global 2000 companies. And we just are really excited to announce we've crossed the 20 million developer mark. So developers really are finding this to be a useful tool. You'll see some of the company logos that are using Postman up here. Long story short, the fact that I know some of you are in high school, some of you in university, if you're learning Postman now, you're already ahead of the game because employers are going to be looking to know if you have this skill because most companies are already using this tool. Postman is not only a great tool to understand, but it also teaches you how to work with APIs. So it's going to be beneficial for anybody that's working with software. Okay, let's finally get into prepping ourselves to make a call to an API. Before we actually call an API, we have to understand a little bit about networking. So we're going to get into request and response. This is the request response pattern in computer networking. Again, these players sound familiar. We have the client, which is whatever entity is making a request. The request will be sent over a network, perhaps the public internet, to a server. So this is some server out on the internet. And that server is going to interpret the request, carry out any, ask for resources or any ask for services, and then send a response back to the client over the network. And that's as simple as that is. It's just a call and a response. But it's important to know the names of the players in the game. We've got the client, the server talking over a network. So how do we make a request to a server? Well, there's really only 2 key ingredients that we need to request a server. That is a method, the how, and an endpoint and a path, which is the where. There's some other extra stuff we can add, something called parameters and headers and body, but we'll start with the basics first. Let's take a look here. This is a screenshot from Postman of how you would compose a request. On the left, there's a little drop down where you can choose the HTTP method. Now, there's a lot of HTTP methods out there. Some of the more common ones are shown in this chart here. We've got get, post, put, patch, and delete. All of these methods are conventions that map to certain operations when we're dealing with data. So for example, have you heard of CRUD, C-R-U-D? It stands for create, read, update, delete. And those are kind of like the minimum viable operations you need in order to interact with the database. You have to be able to add records, you have to be able to read them, you should be able to update them or edit them and delete them. Get, post, put, patch, and delete map to those CRUD operations, where get would be for retrieving data or reading data. For example, at the restaurant, you could probably get the wine list for the day. You aren't changing anything in the kitchen, you're just asking for some data. A post request, that's when you send information. This might be when we place our order. We ask the waiter, we would like 2 hamburgers. And that's the data that we're sending to the back kitchen in order to have our order processed. Then there's put and patch. Let's say, oh, I changed my mind. I don't want the hamburger. I actually want the tacos. That would be a patch request or a put request. A lot of people ask, what's the difference between put and patch? Well, it's very nuanced, the difference, and it's actually has to do with a word called idempotency. And if you ask a lot of computer science people, they might have a hard time answering the very minute difference. A lot of people that code APIs kind of use these interchangeably. Basically, put is used when you completely change the record. Patch is used when you partially update it in conventions, but sometimes they get mixed up. Finally, we have delete, which does exactly what you say. Let's say, oh, I forgot my wallet. I actually can't pay for this food today. I'm going to cancel my order. You might send a delete request to your waiter. All right, so those are the basic HTTP methods that you should be familiar with. The other thing we have to tell is where is this server and what path on the server are we talking to? So that's where we have the request URL up here. And we could break down a URL into several parts to kind of understand its anatomy. The first is all URLs have a protocol. You might have seen HTTP, HTTPS, HTTPS for secure. This is like an encrypted connection. The protocol will come first. And then we have what's called the host. And this is the actual, nickname for the server. This is, masking an IP address out there. This is google.com, for example. So we're asking to hit Google's server. At the very end, you'll see there's a slash. And what's coming after the slash is what's called the path. This is kind of like the local address on the server. So on the Google server, there's a search path. And when we hit this path, we get the Google search page. So this has been a lot of theory. Let's actually test this out. I know you've probably been to Google before, but we can just go ahead and do it up here. All right, so I've opened the browser and I've gone to google.com. Zoom in a bit. What we can do is right click on the web page and click inspect to see what's going on behind the scenes. That's going to open up the browser dev tools here. And there's a network tab that's going to show all of the network activity that happens when we hit this page. Right now, you don't see a whole lot. That's because we have to refresh the page and actually see what happens when we hit the page. And we see, wow, there's a ton of network requests that happen when we hit google.com. Some of these are fetching image assets like the logo. Some of these are fetching CSS or style sheets to make the Google site look like it does. What we're interested in is what actually comes back when we hit google.com. And I can see that right here. So if I click on the google.com request, we can see some information about the request. So what our browsers are really good at doing is making GET requests. And we can see that's exactly what we had done here. We made a request to google.com with a GET method, because that's what's actually happening when we press enter in the URL bar up here. The browser defaults to a GET method. And we got back some more information we'll talk about later. Let's take a look at what came back from the server. I'll click the response and we see a bunch of text. What should jump out is we see we're getting back an HTML document. And this document here is actually what's being rendered right here on this page. So we made a request, a GET request to google.com and the server sent back an HTML document. Browsers are very good at rendering HTML. That's what they do. So that's why we see this rendered HTML document here in our browser view. Now, what I'm going to do is do the exact same thing in Postman to show how Postman gives us visibility into network requests and response. So the first thing you should know about Postman is it's free, which is awesome. The other cool thing is you don't have to download anything. You can use Postman right in the browser. So all you have to do is go to postman.com. And I've already signed in, I'm logged in, so I'm automatically going to be taken into Postman, the tool. If you're trying this at home, you'll end up at like the Postman main website, your first visit. In the upper right, there's an orange button where you can sign up in seconds for making a free account, and then you'll automatically be in the tool. So once you're in the tool, you'll see something like this. This is the welcome screen. I'll make it a tiny bit bigger for you. And the most important thing to know is in order to do anything in Postman, you have to be in a workspace. So the first thing I'm going to do is click the workspaces dropdown and create a workspace. And this is going to take me to a form to define my new workspace. We'll call it Hydra Hacks or Hacker Cup. That's actually what you guys are doing now. Hacker Cup. And Postman gives us the option to either make this a personal workspace that only I can see. Since I'm on a team of people, I could choose to share it so everybody on my team can see it. I could even choose to make this public so that anyone on the internet can come by and see it. I'm going to make it a personal workspace because we're just sharing it here on this live stream. I'll click Create Workspace. And we've been teleported into our new workspace called Hacker Cup. All right, so our goal here, remember, we're trying to make a request to google.com. In order to make a request in Postman, all of our requests live in something called a collection, which is a fancy way of just saying a folder of requests. So since we have no collections right now, I can either click the Create Collection button or the little plus sign up here to add a new collection. And we can just call this one Google, because we're going to be making some Google requests inside. Now I can expand and click Add a Request to add our first request. So here it's giving me a panel to name our new request. We'll call this one the Google homepage. I'm just going to go over to Google, copy this URL, and paste it right here. Remember, our browser is making a GET request, so we're also going to make a GET request. But I will point out, if you click on the dropdown, Postman shows you all sorts of request methods that you can use. We went over, get, post, put, patch, delete already, but you can see there's a bunch more here too, and depends on the API. Spoiler alert, you'll never be able to know for certain what method and what endpoint to use because every API is coded differently. You'll always have to read the API documentation. But we haven't quite gotten to APIs yet. We're just playing with network requests, talking to Google website. So I'm just going to make this a GET request like we did in the browser and hit send. And what's going on here is Postman sent our request, our GET request to Google, and Google sent back a response, which is what we see in the bottom half here. Now, we're actually seeing the exact same information that we saw in the browser here, except this is all smashed together. And Postman has made it indented and colored. You can expand and collapse different tags in here. So all in all, it's like much easier to read this. What else is cool is you can save this response. Whoops. If on the right here, you could save the response as an example, or you can save it to a file. So if I click save as an example, you'll see right underneath the request, there's now an EG Google homepage showing what would come back from the server. Now this is cool because somebody, if I was sharing this with somebody, they wouldn't even have to send this request to know what comes back. They can just take a look at this. And with APIs, sometimes there's a limit to the number of times you can call them in an hour. This is a great way to see what comes back and take a snapshot of what it looks like. All right, so we've gone over how to add a method and how to add a request URL. Let's get a little bit more granular with things we can do in the request. We can add something called parameters that give a little extra information. Now there's two types of parameters out there. We've got query parameters and path parameters. We'll start with query parameters. you know it's a query parameter when you see a question mark at the end of the URL. And maybe you've noticed this when you're browsing the internet. Anything after that question mark is key value pairs, just strings. So for example, here, the query parameter started the question mark. We have a Q equals cat. So the key here is Q, the value is cat. Q happens to stand for query on the Google website. So this is when you're making a search query for a cat. And you can have multiple parameters. You separate them with an ampersand. You can think of the ampersand kind of like a comma in between your parameters. So I'll even show you this. If we go to Google and type in Hydra hacks, I'll close the network tab for a second. You can see, maybe you can't see, I don't know, it's very tiny. We got redirected to a /search path on the Google server here. And right after that, there's a little question mark, meaning we've started our query parameters there. And you see the first thing here is Q equals Hydra plus hacks. That means our search query was Hydra hacks. Then there's an ampersand and another query parameter pair, source equals HP. I don't know what these mean. These are Google's ways of tracking us, I'm sure. And I apologize for the New York sounds outside. But you can see Google has added a lot of query parameters. It will pass soon. This is very hard to read in the browser. So what I'm going to do is just copy this whole thing. Control A, Control C, and head back to Postman. And this time, I'm just going to duplicate our existing request because we're also hitting Google. It made a copy of the Google homepage. I could rename this to Google search. And remember, everything in the browser is a GET request. So I'm just going to paste the URL in here. You see how long it is? Wow. But the cool thing is Postman has extracted automatically all of those query parameters into a much more human readable format down here. You can see the keys and values are in this table. We've got Q being Hydra hacks, source, HP, EI, blah, blah, blah. This is kind of fun to play with, like when you're browsing the web and see exactly how web pages that you're using, what they're sending back. Also, what's cool about Postman is you can toggle these on and off. So let's say I want to get rid of all this crazy stuff that Google is tracking about us. I can toggle them off. And you'll notice as I toggle, Postman updates the request URL in real time. So you can either, change your search down here or change it up here. Personally, I find it much easier to work in the table than to look for the ampersands and not make any typos up here. We've got a question in the chat from Srihita. What are examples of other keys like queries? I'm not sure I quite understand the question. If you could clarify, we'll definitely cover that one. Yeah, so I'm going to uncheck all of these and then send a request. We're getting back an HTML document from Google's server. The cool thing about Postman is when HTML comes back, you can click this little preview tab and it's going to show you an example of that rendered HTML. So here we see the Google search page, should look familiar. And you'll notice that Hydra hacks is pre-populated in the search bar. This is because in our query parameter, we added this extra information. Our query is Hydra hacks. And to prove to you that this will change, we can make a Google search right from here. Let's look up Postman. I'll change it and hit send again. And now Postman is in the search bar and we're getting back Postman results. So that's another way you can Google search, is just changing your query parameter in the URL. But mainly this is to show you where query parameters show up after the question mark and how they're structured. They're key value pairs with an equal sign in between them, separated by ampersands. All right. There's one other kind of parameter out there called a path parameter, and it might be easy to confuse the two in the beginning. It's not that hard to understand. The path parameter comes directly after the slash in a path. It doesn't have to be, sometimes your path might have multiple slashes, but if you see any dynamic chunk in your path, you'll know that that's a path parameter. For example, let's say you have a bunch of photos in your API and each photo has an ID. Right after the slash in the photos path, you might have a changing ID depending on whatever photo you're sending back. So that would be a path variable or path parameter. Oftentimes path parameters are used to hold ID values. For example, if you go to the Twitter website, it might be like twitter.com/postmanlabs or / some other username. That part of the path on the server is dynamic, making it the path variable. So easy to get confused, but just remember, if you see a question mark, it's a query parameter. If it's a dynamic chunk of the path, it's a path parameter. Okay. Other things we can add to our request is metadata in the form of what's called headers. You could think of the header as like the information on the outside of an envelope. It's not actually the letter that you're sending, which is inside the envelope, but it has important information about how to send that letter, who it should go to, whether or not you've paid for postage. It's all on the front of the envelope. So that's what headers are. They're metadata about the request. Some things that you might see in headers is something called authorization. For example, if every API in the world was open for anybody to call it, people could be making tweets on my behalf without my permission, or they can be reading my private messages, and we don't want that. So many APIs are protected, making sure that a request is authorized to be making that request before it sends back data. That authorization information is usually in the header. There's other ways to authorize as well, but header is one of the common ones. Other things you might find in the header are cookies, what type of content to expect back from the API. Don't worry about this stuff. The cool thing, if you're working with Postman, I'll give you a look, is remember the top half here is request world. There's a headers tab when we're making our request. Postman's automatically added some common headers here, like host, user agent, except you don't know what these are, no problem. Postman has a little tooltip that's going to say why this header is recommended and what exactly it means. This is a great way to kind of understand some, fundamental HTTP, networking basics. Yeah. So don't get too much worried about headers. An API's documentation will tell you if you need special headers. Okay, finally, in the request, we can have something called a body. That is the actual data payload. Remember how we said you might make a post request to send an order to the back kitchen? Well, how are you going to send that data? You're going to send it in the form of a body on your request. And you'll often see bodies used on post, put, and patch requests because those types of requests require adding data or updating data. It needs to know what data to work with. And there's several different types of data that you can send to an API. Always, it depends on the API. You have to read the documentation, but some common forms are form data. Let's say you're signing up for an account, you fill out a form, you can send form data to an API. JSON, which stands for JavaScript Object Notation, doesn't mean that the API or your application has to be written in JavaScript. It's just a way of organizing data. And it looks like this, where you open and close a curly brace, and inside is key value pairs, where the keys are strings, and the values can be strings, numbers, Booleans, other objects, arrays. That's what JSON looks like. And it's a very common format for sending data over a network. We'll be playing with JSON later today. You can even just send plain text. You can send HTML, XML. You can upload files to an API. You can make what's called a GraphQL query and much, much more. Postman's going to help you out. Again, just like the headers tab, there's a body tab. So let's say we were making a post request someplace. We could click raw and choose text or JSON. And then we could start typing a JSON body in here. So like my variable, oops, and foo. And now if we were to send this request, there would be a body attached to it. So that's as simple as adding a body is in Postman. All right. We've been talking about requests so far. What's actually coming back? Well, we saw the bottom half of Postman shows us the response from the website or API. To be honest, a lot of the elements you've already learned, like headers and body, also come back in a request, or excuse me, a response. One new element is we get a status code back. So status codes, don't freak out seeing this chart. There's nothing here you need to memorize. If you take anything away from here, just know that the response status codes that come back from an API have a special trick. All of the first number of each status code represents a category of type of status. So anytime you get a response code that starts with a 2, we call that like a 200 level response. That's good. That means your request was a success. Maybe you noticed in Postman down here in the response, it says status 200 okay. 200 is like the standard thumbs up. Your request went fine. So we strive to get 200s when we call APIs. There's other like nuanced ways, like 201 is successfully created a new resource. Usually if you make a post request that went well, you'd get that. 204 is like when it's a success, but the server sends no body back. It just gives you like a silent thumbs up. Then any status code that starts with a 3 represents redirection. So let's say a resource moved on the server and you called the old path. You might get like a 301 saying that we're redirecting you to another another request. 400 level errors. These are client errors, meaning that the client or the entity doing the request made a mistake. You'll often see like a 400 error if you've sent poorly formatted data in your request body, for example. They wanted a string, but you sent a number, you might get a 400. And then all these authorization errors, like you tried to delete my Twitter account via the API, but you're not authorized to do that, you might get a 401. Probably you've seen a 404 error when you're cruising the web. This stands for not found. So if you try to access a resource that doesn't exist, you might get 404 back. Lastly, and certainly not leastly, there's 500 level errors, and these are server errors. And basically you can't do anything about them. This is when either the server you tried calling is on fire, too many people are trying to call that server, so it's slowing down and not responding quickly enough. You might get a gateway timeout. 501, like you tried calling a method that doesn't exist on the server yet. So yeah, again, don't memorize this chart. The great thing about Postman is you can always hover on whatever status code comes back from your response. Postman's going to explain what that means and even gives you the little nickname like 200 OK up here, or 404 not found will show up here. So it's a great way to learn the status codes, and eventually you won't have to look them up. You just know them off the back of your head, back of your hand. We have a question in the chat from Hita. Can you scrape a website non-manually using Postman? Yes. For those of you that aren't familiar, scraping is when you make a GET request to get the HTML from a website, and then you use some code to pluck things out of the website that you want. Oftentimes we'll scrape when there isn't an API, because API is always the preferred way to get data. It's a guaranteed format every time it comes back. Scraping, the website structure might change if a developer changes how the Google page looks like, for example. You can't scrape all the results anymore. So scraping is a gray area topic. Sometimes it's illegal to scrape data. I won't condone it or condemn it either way. We're going to be talking about APIs today, though, and that might help you get data more easily. All right, so again, up until now, we've been talking about network requests in general. Calling the Google website isn't necessarily calling an API, which is just visiting a website, getting HTML document. We want to actually talk to an API. So we're going to practice that with the GitHub API today. And for those of you that aren't familiar, GitHub is a repository hub where people can upload documents and do version control. And that's why GitHub is very popular with developers, because code needs to be version controlled. So a lot of GitHub is dedicated to code bases. Maybe you have a GitHub account. If you don't, I'm just going to show you what it looks like. So if we go to github.com, this is what it looks like if you visit the website. So we're logged in here. This is my account. We can click and see my repositories. And repository is like my code bases. And you can see a bunch of repositories I have. Let's click on this one. Power of Vegetables is a website. And you can see the code is in here. This is great. Like I can click around the website. I can get information. I can see the user here is me. You can click and like get user information. And let's say like you're building an application and you want to get, you want to build a registration service for Hydra Hacks, and you just want them to enter their GitHub username and you get all this information like their location, how many followers they have, what type of coding languages they like to use. You could scrape this website by hitting github.com/ClaireFro, going through all the divs to find this information, but you'll be in trouble if GitHub tomorrow changes the way this website is structured, because there's no guarantee the website will always look like this. That's why APIs are awesome, because it's a contract. They promise to always send the data back in the same shape.
And so in addition to a great website, GitHub has an API. So if you just search GitHub API, actually, if you add docs at the end, that's always a good way to find the documentation and hit search. You can see GitHub has what's called a REST API. There's many different architectures of API out there. REST is one. We'll be using that today. So this is a documentation for talking to Google programmatically using an API instead of clicking around the website. And you can see on the left here, there's a ton of stuff you can do in the Google API. You can like look at a repository's issues. You can look at organizations. You can look at repos, repositories. You can look up users. You can search repositories. All of this you can do programmatically instead of clicking on the website. But before we dive into that, when you're working with an API, you have to know what its like base URL is. How do you make a request to this API? So usually somewhere in the overview, there's going to be like an example request you can use. Here, you can see all API accesses over HTTPS and access from this URL, api.github.com. So I'm just going to copy that and paste it into Postman. So we're done with Google for now. I'm going to make a new collection and call it GitHub. So we can poke around GitHub. And I'm going to add a request. Again, you can structure your workspaces however you like. When I'm working with different APIs, I like to make a new collection. Let's just, what are we trying to do? We're going to try to get a user from GitHub. So let's say the get user info is the name of this request. I'm going to paste the base URL into our request URL, make it a bit bigger. And now we're halfway there. I'm imagining it's going to be a GET request because we're getting data, but we'll have to check the documentation to be sure. What we don't have yet is a path. This is just the host, right? So how are we going to, we can't just guess. We'll have to look at the documentation. Remember, we're trying to get users. So if I click on the users section of the API docs and I click users here, it's going to tell us all the stuff we can do about users. Here you'll see examples of what each thing is. So this one says, get the authenticated user. Remember, if we're using authorization or authentication, that means we have some info in probably our headers that say we're logged in. We're just going to get public data, so without logging in. This is stuff you can even update the user, like change their name, list all the users on GitHub. We don't want that. We just want a user, get a user. There we go. All right, so the documentation, there's a lot of stuff here. I would like our attention to be drawn to this right here. We can see that it's a GET request. And you notice it's starting right at the slash. API documentation won't usually include the base URL because it's the same on all of these endpoints. We already got the base URL. What they do show is the path. So this is the part that's actually the location of the operation on the API. To get a user, we have to say /users/ and then you can see username is here in curly braces, which is representing that this is a path variable. The username can be anything. So I'm going to copy the path and smack it right onto the end of our base URL on the same line. And you know, the double curly brace or the single curly brace is one way of denoting a path variable in documentation. Postman uses another one that's also common, which is just 1: right before the path variable. And you notice as I typed that, Postman added a path variable table down here. So now we can see that our path variable has a nickname of username. We can give it a value. I'll use my GitHub username for now, Clarefro, and hit send. And what this is actually going to do is make a request to /users/Clarefro. Postman's going to insert that right in here. So I'm going to hit send. And what we get back is data about Clarefro. And you can see already why this is so much more useful than scraping. GitHub is always going to send back a response that is JSON object that has this data. It has login name, it has the GitHub ID, avatar URL. Let's say like in the Hydra Hacks registration automation, you wanted every user to have an avatar. You have the avatar URL from GitHub. I'll click on that and see what comes back. This is my GitHub avatar. What else do we get? We get all these links to different parts of my account. You can see my name, you can see my old location. If I had Twitter, it would be here. You can see when I made my GitHub account in 2014. So you can get all this information programmatically instead of actually accessing the website.
Why is this cool? That makes it easy to integrate into your application. We'll get into how to do that in a second, but just to prove to you how path variables work, would any of you like to share your GitHub username if you aren't opposed to having your data shown publicly here? The data that you can get from the public GitHub API isn't too sensitive. Pretty generic stuff like number of repos, number of followers. If you'd like, anyone likes to share their GitHub username, you can do so in the chat. All right, we've got one from Marianne with many N's. I'll copy that. We got a couple coming in. I'm going to replace Clarefro with Marianne and hit send. And now we're getting data back, exact same shape from Marianne. And you can see, let's take a look at the avatar. Another GET request is just the generic automatically generated avatar. You can see name, you can see a bio, you've been a user since 2018. Awesome. So again, I'll prove it one more time. I can just paste another username in here, send. We've got another avatar. Nice. And you can see, the bio, user since April last year. So really cool. Like you can totally think of ways that you can use this information in an application. And remember, this is only a small fraction of the things you can do with the GitHub API. For example, you can get a user's repositories. So if we go to the repositories section of the API, let's see, you can list organization repositories. Oh, there's even like a menu over here. If you want to say get a repository, list a repository for users, do they have that? Yeah, list repositories for a user. You just say /user/username/repos. All right, we can do that. Cool thing about Postman is I can just duplicate our current request, so it's pretty much the same. We'll call this one get user repos, and I won't put you on the spot anymore. I'll just use my username again. And we have to change the path to be /user/username/repos up here. I'll save it and send. And what's going to happen is it's going to send back all of my repositories. We got a 200 response, means okay. And you can see there's the first repo here is Clarefro/personal npm package. You could scroll through here for days and see all of my many repos or anybody's repo, your friends. What's cool here is you might even see like what types of languages are used in the repo, I think is on here. There's a URL that goes to all the languages used. Let's see what cool data we have. You can see how big the repo is. Yeah, here's a language attribute. So you can see this repo is mostly written in TypeScript. You could map through a user's whole repository list, see what their most commonly used languages are. You could do like some statistical analysis on this. So yes, APIs are cool for integrating applications. They're also cool for data analytics because it's a great way to get a ton of data. The Twitter API, for example, you can like programmatically fetch a bunch of tweets, do some sentiment analysis with another API. You can see how APIs really empower you to do a lot of things. Now, I just want to leave you with one more thing before we open up for the Q&A. So far, we've learned how to make a request, how to view a response, what APIs are all about. How will we actually use this in a project? Because up until now, we've only been playing around in Postman, the tool. Well, Postman's also here to help you out in that last step. Every request that you create in Postman, over on the far right, there's a code tab. So I'm going to expand that. And we'll see we get a little snippets generator. This is going to teach us how to make the exact request we've built in Postman in tons of different coding languages. It's like PHP, there's Python. Here's how you do it in Python. Here's how you do it in Node.js with the Axios library. Really cool. You just copy this and paste it into your application. Here's how you do it in Ruby, for example. So that's the final step. If you were building a JavaScript application, for example, you might use the JavaScript fetch library to do this. Just copy this. Whoops. There's a copy button here. You copy this and then put it into your code. Just to give you an example of this, let's try curl, the old-fashioned way of making an API call. I'll just copy the curl command and open up my terminal. And I will clear it before bringing it over. Here we are. All right. Oops. And make it a bit bigger. All right, so I'm just going to paste what I copied in the Postman snippet generator, and it's going to make our, what was this request? The get repos request for us. And wow, that's cool. This exact same data is showing up right in my terminal. Obviously, this is a ton of data. I have like over 200 repos, so it doesn't even fit in my terminal. And again, this is why Postman is great. At least it's indented in the terminal, but what's nice about Postman is it's colored. I can expand and collapse everything. I can save it. I can see the entire response. It's going to make my life easier if I'm trying to do data analytics, figure out how to map it into my application. So that is a whirlwind intro to APIs and Postman. Today, we just played around with GET requests, but I invite you to play around with API documentation. The documentation for whatever API you're working with will tell you exactly what method to use, what endpoint to use, what parameters to use. So now you know all the terminology. Yeah, we learned all that. I will share the slides in this chat. Actually, I'll do that now before you all leave. And I've created a public workspace in Postman. If you join Postman for free, you can check this out. I'll just give you a quick preview. This is basically what we did today, and then some more advanced stuff if you want to continue playing around. What we did today was here in the basic GitHub API 1. We did searching for repos, we didn't do it. We did user info and user repos. You can see those requests here and play around with them yourself. There's also an advanced, which will show you how to authorize. So you can log into your GitHub and do more advanced things like creating repos. You can edit your repos. And be careful, you can delete your repos too. So yeah, you can read the instructions over in the documentation tab right up here. You can follow that open and closed to understand how to do that. Yeah, and one thing you'll notice if you look at this that we didn't cover in the lesson, you'll see there's like this orange base URL in double curly braces here. Postman lets us use variables so we don't repeat ourselves. And oftentimes we use a variable for the base URL because it's in every request. So here, if I hover, you can see this base URL resolves to api.github.com. That's set on our collection variable. Yeah, just be aware that that's what that is. You can look into the Postman documentation if you're interested in learning more about variables. It's a really fun way to make your development more efficient. But yeah. Oh, we had somebody in the chat wanting to use the Yelp API. I've been playing around that API, and Postman has some examples of it as well. It's a great way to search for restaurants programmatically and use it in their apps. It's a great API. One thing about Postman is you can search up here. Like I can look up Yelp. It's going to look through all of Postman's public network to find Yelp collections. You have to do a little bit of sleuthing because anybody can upload a public collection, and maybe you have some like fans of Yelp that make some, but I always suggest API Evangelist because that's one of our employees here at Postman. And this is going to show you all the things you can do in the Yelp API, like searching for business. You can see an example of how you would do that. And you would put your search term in here, for example. So if you find anything interesting on Postman's network, you can always click the dots on a collection and say, create a fork. This will make a copy of the collection for you to play around with. Obviously, since this is not our collection, I can't even send this request until I create a fork. So same for you. All right. Okay, I do want to open up for questions. I just want to have one last word. If what you learned today was interesting to you, I have some more continued learning you can pursue. We have what's called the Postman Student Expert Training, and it's a self-paced training you can do for free to learn more about APIs and more advanced features in Postman, like writing scripts. By the end of it, you'll have completed some API calls yourself, building requests, and you'll also be given a badge. It looks something like this, Postman Student Expert, that you can share on LinkedIn on your resume to prove that you have Postman skills. It also would make you eligible to apply to become a Postman student leader, if that's interesting to you, where you'd be talking about APIs, doing workshops like the one I'm doing on your campus. We give you monetary support if you want to have pizza at your workshops. We give you moral support. We give you materials. So do check that out if you become a student expert. Again, the links are in the slides that I shared in the chat. I will say we're about to update the student expert training, and it's going to be the exact same training, so it's fine to do it now, but it's going to change soon, the name of it, to something also cool. Just heads up. All right, Postman student expert, here's the link in the slides. We also have a Discord. If you ever get stuck, we can give you help in real time. There's also some fun challenges there regularly. We give away swag. We do little hackathons with APIs. So feel free to join our Discord. Lastly, this is for educators. So if you think any of your teachers might be interested in using Postman in the class, we do offer free Postman licenses to educators to use with their students. So you can point them to our Postman classroom program on our website, and we're happy to talk to them and give them a free Postman license and some teaching materials. And thank you, HydraHacks, for sharing the Discord link. Yeah, it's in the chat now. Okay, last thing, I promise. I do want to leave you with some resource where you can actually play around with real world APIs. I've put together a little list of some free APIs out there that are fun to play with, just to show you how to use it. It's hosted on GitHub. There's just a couple APIs that might be fun to poke around. There's like COVID data APIs, some environmental APIs like finding air pollution, finding electric car charging stations, doing astronomy type of things. What else? We got the Twitter API in here. Finance, let's say you want to do some like currency conversions, and New York Times, you want to get the news, for example. So this is a short list of APIs that are really simple to use, except Twitter is a little complicated. If you want a longer list, there's even one here that is like kind of the canonical public APIs repo on GitHub. You can see there's a lot of categories here, pretty much everything you can think of. And it will give you information on whether you need to have authorization or not. So really have fun. Again, one of my favorite things to do is just to like do a Google search for your favorite service and add API at the end. Usually there's an API for your service. Yes, okay, I am done talking. We have about 5 minutes left, and we've got some questions in the chat. Can we add you on LinkedIn? Absolutely. I'll remind you my name is at the beginning. Yep, I'm Claire Froelich. I'm also on Twitter here. Yeah, but I would like to open the floor to any questions. Sorry, my nose is running. Got that summer cold. Yeah, so any questions about APIs, about Postman, web development, happy to answer to the best of my ability. I've only been a web dev for about 2.5 years now. All right, Hita asks, how would you link the data that you get in a database? Could I find an easy tutorial for that? So great question. Oftentimes APIs are used as a way to talk to a database, to add data, update it and delete it. To answer your question broadly, every database is different, but there are a ton of tutorials online. You could even use Google Sheets as a database and call it with an API. But there's other types of database. You can build an API using Node or Python that is like a layer on top of a Postgres database or a MySQL database, or even like MongoDB. Whatever tech stack that you like. If you type how to make a MongoDB API, for example, Google's got your back. And we actually have, if I have a chance to search for it on YouTube, if you look up Postman building APIs, there's a lot of ways that Postman can help you build your API. We've done a tutorial on how to build a Node API with a database. So check that out. Are there any tutorials posted by the Postman company on YouTube? Yes, we have a ton of tutorials. I will share the YouTube link in the chat. We have a very active developer relations team that's always putting out awesome content and does live streams constantly and puts the recordings up. They do some really fun live streams like hacking a Roomba live using APIs. There are all sorts of cool stuff. So I'm going to get you the Postman YouTube channel here. All right, so I'm sharing it right now in the chat. All right, if you use a social media platform API, how would you display the info you get back onto the website? And how would you do that with several accounts and transfer it to a comprehensive structured display? Great question. So any data that you get from an API, you can handle however you want. If you are building like a client-side application that's only front end, you could handle all of the data that comes back from, let's say, the Twitter API right there in the browser if you wanted. You would just map over your data. And let's say you like got a list of tweets, you could map over each one. Since you know exactly the shape, you could say like, put it in a div that looks like this, that using like a templating agent, templating engine, or even like vanilla JavaScript to create new elements in the page. Excuse me. As to your question about how would you do that with several accounts and transfer it to a comprehensive structure, well, when you're working with social media and you might get involved with like authorization, meaning you probably can't do everything in the front end because you'd have to reveal some secrets, like secret API keys and secret passwords and stuff. So you might need to build a server to do that. So it really depends on exactly what you want to do. But again, you always know exactly what shape of data is going to come back from the API. So you can use that in your application however you want. You can kind of shape it with your code. And for those of you that are maybe like a little bit less familiar with web development, another cool feature in Postman is we have this visualization tab. So if you click visualize here, you see it says there's nothing, but you can write some code in Node. If you look up like Postman visualizer in our Learning Center, you'll get much more detailed explanation. But there's a test tab. And basically any code that you write in here in Node will be executed when a response comes back from the API automatically. So like, for example, I could say count the log, hello world. And if I hit send, where's the log? Right in the lower left, there's a console. You can see now it says hello world down here. If I wanted to add something to the visualizer, I could make some HTML or like a template. I'll use backticks instead of double quotes because backticks let you make multi-line strings. It just makes it easier to type some HTML. So I'm going to make like a hello world template here. And that's our HTML. And now all we have to do to get it to show up is say PM for Postman. It's a special helper object, .visualizer, .set. We put our template in there. Oops. Template. Now, if I hit send, we can see there's hello world showing up in the visualizer. We can inject data in there. So for example, this is the repos request. The response that we get back looks like this. Let's say we want to count all the repos that came back. I can go back to our test and let's say we want to get the body of the response. So I'm going to make a variable called body and say pm.response to get our response data. We want to get the JSON response back. So say .json. I'm doing this very fast. Don't worry. I just want to show you something that's cool to do. And if we want to get the number of repos, const number of repos, we can just get the body. And what does the body look like here? It's an array of objects. So we just like get the length of the array, I guess. That would be the number of repos. Now I can, as a second parameter in our visualizer, send in the number of repos. And now I can use it in our template. So I could say here, number of repos, and use double curly braces to inject our variable number of repos. And then close our p tag. Now, if I send this again and go to the visualize tab, you can see that 30 repos came back. And this will change depending on whoever you call dynamically. So this is a cool way to practice, writing HTML and injecting data from the API response in there. Check out Postman Visualizer if you're interested in more of that. I'll just answer this one last question since we're at time. But Jennifer asked, let's say I wanted to do a playlist thing of songs, and what I wanted to retrieve from the API is the title and artist name. And the question is, in order to search for the clean version of these songs in the playlist, I need to use a YouTube API. Okay, so you would need to find an API that allows you to search for clean songs. Your thought process is very correct. You would have to find an API that does that. put in a search query. You'll never know exactly how to do it until you find the API. I will say Spotify music has a great API that's really got excellent documentation to get you started. It does require authorization, so you have to read the documentation on how to set that up. Postman will help you with authorization here in the authorization tab. Spotify, I know in their song track responses does have like explicit true or false. So you could filter through the responses from that API when you're searching for tracks to only show the non-explicit versions. Yeah, you could make an app like that I would use the Spotify API, but maybe there's other music APIs out there. Okay, I have taken up your time. I do want to give you time to hack. And yeah, thank you all for listening. If you have any questions, feel free to reach out on Twitter or LinkedIn, or even better, join our Discord so you can ask all of our Postmanauts and other students. You'll get answers much faster. Yeah, so thank you all. Cool. All right.